Have you ever needed to use a bearing for something and then remember in a world where a half gallon of milk is $5, no way your broke self can afford to use a real metal bearing? No? Just me? Well, regardless, I have the perfect solution for you. Introducing 3D printed bearings. Wait, what's a bearing? Let me break it down for you. Whenever you want to make something spin, like a wheel, it needs to revolve around one point, called the axle. There's one problem with this setup though, and it's that there would be a lot of rubbing between the wheel and axle when it tries to spin, which causes friction to reduce the spin time and speed. This is where bearings come in. The most common type of bearings are ball bearings, where you have two rings separated by spheres. Spheres are great because they allow for rolling friction rather than sliding friction. The rolling motion of the balls minimizes resistance between the moving surfaces compared to sliding, which reduces energy loss and heat generation. With this setup, we get something that spins quickly and for a long time with minimal resistance. Now you may be thinking, that'll never work. 3D printers are notoriously bad at printing spheres. But who said they had to be ball bearings? These circumstances call for innovation, out-of-the-box thinking, which is why I say that we make our bearings a little more 2D. Okay, this idea isn't entirely or even a little bit original. Roller bearings, made with cylinders instead of balls, are commonly used for heavy loads and feature cylinders because they offer a greater surface area for load distribution. So, we have a roller bearing, but we can't print that just yet. All these cylinders will immediately fall out of the bearing when we try to print it. So what do? Well, the goal here is to make a print-in-place design that doesn't require any assembly. So we can't use covers that we would have to snap on, and instead we can introduce grooves to the design. I call these V-shaped bearings, but they really look more like X's. Looking at the cross-section here, you can see that the grooves between the balls and the rings hold the balls in place, keeping them from being able to shift up or down significantly. In order to make this design, I had to keep in mind the 0.2mm printing tolerances on most 3D printers. So the clearance between the balls and the rings is 0.2mm. Now that we have our first prototype, let's print it. So after 9 rounds of prototyping, where I tweaked both the number of balls and the clearance between the balls and the rings, we end up with something like this. Now, if you look closely, you'll see that as the bearing runs, the balls actually roll and slide at the same time, falling and being pushed back up as they slide. So this system isn't totally efficient because it is losing a lot of energy to that sliding friction. Basically, if you have the means to, use real ball bearings. But when you just need a means to an end for a dumb project, 3D printed bearings are a great and affordable choice. Stay curious.